Imagine you're floating through space. Ahead of you is a dark sphere so powerful that not even light can escape its gravity. As you get closer, time begins to slow down. The stars behind you become distorted. Then, without warning, you cross a point of no return. What happens next? Do you get crushed instantly? Could you travel to another universe? Or does the black hole erase you from existence forever? Scientists have been studying black holes for decades, yet what truly happens inside one remains one of the greatest mysteries in modern physics. In this video, we'll journey from the edge of a black hole to its mysterious center and explore what science and a few fascinating theories suggest might happen. A black hole is not a giant vacuum cleaner pulling everything in from across the universe. Instead, it's a region of space where gravity is so intense that nothing, not even light, can escape once it crosses a certain boundary. Most black holes form when massive stars run out of fuel and collapse under their own gravity after exploding as supernovae. There are several types of black holes. Stellar black holes, formed from dying stars. Intermediate black holes, larger but relatively rare. Supermassive black holes, containing millions or even billions of times the sun's mass, found at the centers of galaxies. Primordial black holes, hypothetical objects that may have formed shortly after the Big Bang. Despite their enormous mass, black holes themselves emit no visible light. We detect them by observing how they affect nearby stars, gas, and light. The event horizon is often called the point of no return. Outside this boundary, escaping the black hole is still theoretically possible, but once you cross it, escape becomes impossible because the escape velocity exceeds the speed of light. Surprisingly, if the black hole is very large, you might not notice anything unusual the moment you cross the event horizon. There is no solid surface or dramatic wall. You simply continue falling inward. However, to someone watching from far away, something very strange appears to happen. Because of the black hole's immense gravity, time slows dramatically near the event horizon. From their perspective, you would appear to move more and more slowly until you seem frozen at the edge, gradually fading from view as your light becomes increasingly redshifted. Imagine falling feet first toward a black hole. The gravitational pull on your feet becomes much stronger than on your head. This difference is called a tidal force. As it increases, your body begins to stretch lengthwise while being squeezed sideways. Scientists refer to this dramatic effect as spaghettification, because your body would become long and thin, like a strand of spaghetti. For small stellar black holes, these tidal forces become fatal well before you reach the center. For supermassive black holes, however, the tidal forces at the event horizon are much weaker. In theory, you could cross the event horizon alive, at least initially. Eventually, though, the increasing tidal forces would become overwhelming. According to Einstein's general theory of relativity, everything falling into a black hole eventually reaches a singularity. A singularity is predicted to be a point where matter is compressed into an incredibly tiny region, and density becomes effectively infinite. At this point, gravity also becomes infinitely strong. But here's the problem. Physics breaks down here. General relativity predicts the singularity. Quantum mechanics describes the behavior of extremely tiny particles. Unfortunately, these two fundamental theories do not agree under such extreme conditions. Because of this, scientists believe the singularity predicted by current theory is likely a sign that our understanding of physics is incomplete. A future theory of quantum gravity may reveal what truly exists at the center of a black hole. Science fiction often imagines black holes as gateways to distant galaxies or even other universes. This idea comes from a theoretical concept called a wormhole. A wormhole would connect two distant regions of space-time, acting like a shortcut through the universe. Some mathematical solutions to Einstein's equations allow wormholes. However, there is currently no evidence that naturally occurring black holes contain stable wormholes. Even if wormholes do exist, most calculations suggest they would collapse almost instantly unless held open by forms of matter unlike anything we have observed. So, while the idea is exciting, it remains speculative. One of the biggest mysteries involving black holes is known as the black hole information paradox. Quantum mechanics tells us that information cannot simply disappear. Yet if everything falling into a black hole is destroyed, where does that information go? This puzzle has challenged physicists for decades. One possible clue comes from Hawking radiation, proposed by physicist Stephen Hawking. According to this theory, black holes slowly emit tiny amounts of radiation and can eventually evaporate over incredibly long periods. The unanswered question is whether this radiation somehow preserves the information that fell inside. Scientists continue to debate possible solutions, and the paradox remains one of the most important unsolved problems in theoretical physics. With today's technology, sending a human into a black hole is impossible. Even reaching the nearest known black holes would take far longer than a human lifetime, and surviving the extreme conditions would present enormous challenges. Instead, astronomers study black holes using powerful telescopes that observe their effects on surrounding matter and the light emitted by hot gas spiraling toward them. The first image of a black hole shadow, released in 2019, provided striking evidence supporting decades of theoretical predictions. Future observatories may reveal even more about these mysterious objects. Black holes challenge nearly everything we think we know about space, time, and reality. We understand how they form. We know how they influence the universe around them. But what actually happens beyond the event horizon remains one of the greatest unanswered questions in science. Perhaps the answer lies in a future theory that unites relativity and quantum mechanics. Or perhaps black holes hide secrets that will completely reshape our understanding of the universe. Until then, they remain among the most fascinating and mysterious objects ever discovered.